Welcome back to part 2 of the Clark Tweed Bandmaster repair. I've got it hooked up to the drop-down transformer, 120 volt transformer, and that's powered via the variac. The variac's turned right down, so the amp is switched on. So what I like to do is bring up slowly the supply voltage, and I'm looking at the current draw. Not drawing any excess current, so that's a good thing. So as I get to 240 volts, the drop down transformer will be supplying around about 120 volts to the amp. I'll just leave it there, that's about 230. So looking at the amp now, we've got the filament voltage. You can see the tube's lit. Heater voltage is there, the pilot light's lit. Now what I like to do, is crucial, is measure the bias voltage before bringing the amp out of standby. It's critical. I look at other techs' YouTube videos, and there's a guy that posts daily videos, and yeah, he powers up via a light bulb, but that won't prevent the amp causing damage to itself if it's brought out of standby and the bias is missing or compromised. So it's very crucial to measure these voltages. So on the grids of this valve, first is this point. Should probably have around about minus 40 volts. Minus 44. And on the grid of this valve, minus 42. There's 2 volts difference, but let's bring it out of standby and carefully see what the amp's doing. The pots are noisy, could be some DC on those, and it's motorboating. I don't know if this mic can pick up the low frequency oscillation. So now let's check that bias voltage again. On the grid of the left hand 5881 we've got 41 volts, which is okay. On the right hand tube, OEC, 12 volts. At that, this tube will be conducting very heavily, and yes, it's getting red hot. So we need to switch it off before it runs away with itself and causes damage. See, if I'd have just let that run, then this tube would have self-destructed, and it could have taken out other components, even the output transformer. My suspicion is the expensive Jensen paper in oil capacitor, that's this one that's feeding this 5881's, is leaking DC. So I'm going to pause the video, lift that capacitor and see if that bias voltage comes up. Okay, we're back, and let's measure again on this point. It would help if I switch the amp on. Tubes should already be warm, so we'll bring it out of standby and we'll check. See if it's come back up, and yes, it's there. It's 43 volts now. So this capacitor's gone, and this tube is drawing. These bias test points are across 10 ohms, not the usual 1 ohm, and that's 350 15 millivolts ish across 10 ohms is around about 31 milliamps, and this one, this bias point, that's about 30 milliamps, so that's good. And the tube's running at sort of normal temperature, it's not running away with itself anymore, so looks as though it's survived. So if that one's gone, well, it has gone. I don't trust that one. In future that could pass DC, could leak and cause problems, and so could the others. So let's just check on these, see if these are passing DC. This one feeds the normal volume port, and yes, that's passing 1.48 volts, so that'll cause this to be noisy. Could even be causing the motor boating. And this one is passing 0.66 of a volt, so that DC will cause this control to be noisy. So the solution is to take all those expensive Jensen paper in oil capacitors and throw them in the bin and change them with something else. So we'll take all the caps out and we'll crack on. But for now, thanks for watching.